This is chapter 5.4, Property of Log Notes, part 4. In this last little section, we are going to simplify a couple of logs, and then we're going to put all of the properties together and expand and condense the properties all together. So simplifying with bases, the key thing that you need to remember here is that logarithms and exponentials are inverses. So if the bases of an exponential and a logarithm are the same, they cancel. So for example, on number 17 here, this logarithm has a base of a, and then you have a base of a with this exponential function. So basically what happens is that the log base a and the a to the cancels out, just leaving you with the exponent. So this is equal to 8. Same thing with number 18. This says log base 3 and 3 to the. So log base 3 and 3 to the cancel out, just leaving you with the exponent. This equals 15. Number 19 looks like a little bit more complicated if you don't remember that this log of 10 is an understood base 10. So log base 10 and 10 to the are again inverses, just leaving you with the exponent, which is 3k. This also works with natural logarithms. So natural logarithms and e are inverses of each other. Remember, e is just a number, 2.71, but ln and e are inverses of each other. So ln and e cancel, just again leaving you with the exponent. So ln of e to the negative 5 is just negative 5. And the ln and e cancel here, leaving you with just 7x. Same thing, very, very easy. Let's look at number 22 here. Express each of the following in terms of sums and differences of logarithms. So we're expanding here. That's what we're doing. We're expanding this and we're splitting these up into these larger sequences using logs. So this number 22 says log base a of x squared y to the 5th divided by z to the 4th. So to expand, what we're going to do is we are going to split it using the product and quotient properties into separate logs and then use the power product or the power property to pull the numbers down in front. So I have an x squared on top, a y to the 5th on top. Those will both be plus signs. Anything on top will be a positive. Anything on bottom will be a minus. So the z to the 4th will be a minus. They all will have log base a in front of them. So this ends up looking like this. Log base a of x squared plus, because it's on the top, log base a of y to the 5th. Then minus, because it's on the bottom, log base a of z to the 4th. Now, if we're expanding, we're trying to make this as in simple terms as possible. The argument needs to be as simple as possible. In this case, our arguments aren't as simple as possible because we have powers on them. So remember that with the power property, you can take the arguments and stick them down in front of each thing. So this then finally becomes expanded to 2 log base a of x plus 5 log base a of y minus 4 log base a of z. That is what we finally make it out to. So this is expanded because each of our arguments do not have anything else to do. There's no multiplication in them, there's no division in them, and there's no powers in them. Now, you can't combine these. Remember that you cannot add logs if they do not have the same argument. Those are not the same. You can't just add these together to be x plus y in the end either. That's it. This is our answer. Let's look at example number 23. Now, before we start number 23, there's a couple of things I need to go over with you off to the side that you probably have forgotten since Algebra 2. So one thing that I want to remind you is that you can rewrite the square root of b in rational powers. Remember, rational means fractions. So this is b to the 1/2 power. If you have a cubed root of b, this is b to the 1/3 power. Remember, the bottom of the fraction fractional power is the index. So if you have b to the 1/4 power, that's the 4th root of b. So keep that in mind going back and forth between these. If you have fractional powers, that means it's a radical. Looking at number 23. So here, the first thing that I'm going to do is change this radical to a fractional power. So this would be log base 2 of a squared b to the 1/2 divided by c to the 5th. So now it looks very similar to number 22. So go ahead and see if you can do this one on your own. Hopefully you got that right. Now we're going to do the last two examples, which are condensing. So express each as a single logarithm. That's basically long words for condense this into one log so that we can later solve the equation in the next section. So here, before when we were expanding, we used the quotient and product property first and then did the powers. Now we're going to go backwards. We're going to do the powers and then smush them together using add or subtract. So the power property is the numbers in front. So here's a number in front and here's a number in front. This one has a negative, but there's no number in front of the log multiply. So first step is to take the powers, put them on their arguments. So here, and notice that they do all have the same base, so we can use the product and quotient properties. So this gives me log base b of x to the 5th minus log base b of y plus log base b of z to the 1/4 power. Now we can use the quotient and product properties. Remember, anything that has a minus sign will go on the bottom of the fraction in the argument, and anything with a plus sign will go on the top of the fraction with the argument. So log base b of, there's one large argument, which ends up being a fraction. So x to the 5th is a positive, so it goes on top. The y is negative, it goes on bottom, and z to the 1/4 goes on top because it's positive. This is an answer that my math lab would accept. It's perfectly fine with that. But one other step that might help us when we start doing the equations is changing that z to the 1/4 into a 4th root of z. So another equivalent expression would be this, log base b of x to the 5th times the 4th root of z divided by y. Those are all the same. Okay, let's look at our last example. This is with a natural log, but with logarithms and natural logarithms, they all have the same properties because remember, ln is really log base e, is the same thing as ln. So it's ln is still a logarithm. It's just called it's a special logarithm, natural log. So let's go ahead and get this one done. This one is a little bit, it's easy to condense, but there's reduction that we haven't gone over before. So here you have two different logarithms. They have the same base. It's log base e, which is also natural log. So subtraction means we are going to smush these together. And on the top is going to be the thing with plus sign in the front. On the bottom will be the thing with the minus sign in the front. So 3x plus 1 is on the top. And 3x squared minus 5x minus 2 is on the bottom. Now here's the thing. We've done rational functions before, right? With the fractions and all the asymptotes and all that kind of stuff. You're going to have to see if this reduces at all. So what I need to do is I need to factor these. So I'm going to go ahead and take a second and factor this guy. So I have 3x squared minus 5x minus 2. Now remember, to factor that, you multiply the first and the last. That gives me -6. Find the factors of -6 that will subtract to give me -5. So 1 and 6, that will give me -5. It needs to be a -6 and a +1. Those are my winners. 2 and 3, they have to be opposite signs, so that won't work. So factoring this, expand it into 4 terms, 3x squared plus 1x minus 6x minus 2. Group them, first two, last two, plus sign in between. GCF of the first set of parentheses is x. 3x plus 1 is left over. GCF of the second set of parentheses, they have the exact opposite sign, so we need to take out a negative, and they have a 2 in common. Then what's left over is 3x plus 1. So factoring leaves you 3x plus 1 is one factor, and x minus 2 is the other factor. So I have the natural log of 3x plus 1 over 3x plus 1 times x minus 2. And notice that the 3x plus 1's cancel, just leaving me with the natural log of 1 over x minus 2. And that's your final answer. So be careful with these that check the factoring. A lot of the factoring is not going to be as complicated as this, but check to make sure things factor. So just as a recap, we have done the product property, the quotient property, and the power property. You need to make sure that you can go back and forth between these very easily so that when we get to equations, it makes your equations easier. If you have any questions, don't hesitate to email me or text me over a remind, and we can hop on a Zoom call if you need to.